Good afternoon, everyone. You are welcome to the Dawn's Consult. I saw a question, one of these wire pass questions, and I looked at it critically. I now discovered that many students may have problems to solve such question. The question is on solubility. I now decided to bring it up here so that you, my people, can have the right solution for it, and of course to learn from it. All right, this is the question. The question says, the solubility of potassium trinitrate 5 at 20 degrees Celsius was 3.0 mole per dm cube. They now say if 67.0 grams of potassium trinitrate 5 was added to 250 cm cube of water and stirred at 20 degrees Celsius. All right, now say determine whether the solution formed was saturated or not, whether the solution formed was saturated or not at that temperature, and we are given the molar mass of the KNO3. So see a question like this, it says you should determine whether it was saturated or not, if the solution was saturated or not. So basically what you need to solve this problem, you need to do calculation first, and maybe you have been taught in your classrooms, and maybe not, but if you have, it will be good for you to remind yourself, and if you have not, you can learn from me now. So let's have it, let's solve it, let's see how it goes. All right, we already know the normal formula we often use when we are dealing with this. We don't have number of moles. All right, when we say number of moles, we use this formula: mass over molar mass. Is that right? Now don't be confused, don't use this mass now, because this mass was added to 250 cm cube. So whatever you obtain, the mass you obtain is what you will compare with this mass to determine if the solution was saturated or not. Okay, so what I need to find here is another mass entirely, using this mole and the molar mass given to me, using this mole and the molar mass given to me. So what I will do here, I will say therefore mass will be equals to, we know that will be number of moles when you cross multiply or you make mass solid of the formula from that equation there, number of mole times molar mass. All right, okay, if you do that, number of moles given to you here, we have it as 3.00, just forget about the mole per dm cube for now, times the molar mass given to you is this 100 here, so multiply by 101, sorry, it's 101, so multiply by 101. all right, when you are solving chemistry questions, try to avoid mistakes. All right, 101. So if you multiply that, that should give you about 303, and our unit will be grams. All right, so now this means that, now I can now explain further. It means that 303 grams of this KNO3, if I may use it that way, of this KNO3 dissolved in, mind you, this is mole per dm cube, so it dissolved in 1000 cm cube, dissolved in 1000 cm cube of solution. All right, or you can use water or whatever, as it was given water. Okay, so now what gram of this KNO3 will dissolve in 250 is whatever you obtain here, you now compare to what was done to know if your solution was saturated or not. 250, this is just a simple way of solving it. All right, so if you obtain this, you cross multiply, so that making S subject of the formula, that will be 303 times 250 all over what, 1000. Is that right? So you can punch with your calculator here. That will be 303 times 250 divided by 1000. All right, if you punch, okay, that will give you 75 75.8 grams. 75.8 grams. So now, to determine whether the solution formed was saturated or not, you compare this 75. What you obtain here now is said to be the standard. Let's use that word, said to be the standard. All right, so the standard should be 75.8. That means the standard that should be used is 75.8 grams, but what was used is 67.0. That means the standard was higher than what was used. Okay, that means what was used was 67.0, and that means more of the solution, more of the solute can still be saturated, can still be put into that water. If they use 67, what I need is 75 to make it saturated. And if they are using 67, that means the solution can still contain more solute. And when the solution can contain more solute, we say it is unsaturated solution. So based on this now, we say it is what? It is unsaturated. I don't know if you understand what I said. It is unsaturated because you can use any of these reasons, because the solution can contain more solute. The solution, because the solution is unsaturated because solution can contain more solute. More solute. Reason being that 67.0 gram is less than what we obtain as what? As 75.8 grams. And that person can say it is unsaturated because 67.0 gram is less than 75.8 grams, which was required. You know, what is required is 75.8 grams to make a saturated solution. And what we are given is 67.0. Now, should the question be changed, or whatever we solved, should it be changed and we obtained exactly this? Exactly this will make the solution to be what? Saturated. Exactly this will make the solution to be saturated. And if it's more than this, what do you think it will be? It will be supersaturated. That means the solution cannot contain more than it contained. I don't know if you understand. So that's how simple it can be. Go through it, and if you don't understand anything, go to the comment section, put your question there. I will be here to help you. That's how easy we can make chemistry in the Dawn's Consult. Mind you, distinction is our target for you, and you can achieve it. See you in the next video. Thank you.